All right, guys, last Keystone prep informational day. 2 things to go over. First, simplifying radicals. Second, simplifying rational expressions. So as you read in the agenda, I don't have a finish line book here at home, so I'm just going to make up some problems for us to go over. We did go over simplifying radicals before, so if I'm simplifying a radical, let's start off with something fairly easy, like the square root of 20. A couple different ways to do this. When I'm first teaching students how to simplify radicals, I like to take the value under the radical and make a factor tree with it. So 20 can be broken down into 4 and 5. 5 is prime, so we'll circle our prime values. 4 can be broken down into 2 and 2. Each of those are prime. So that means the square root of 20 is really the square root of 2 times 2 times 5. Now, 2 times 2, I have 2 of them, right? Remember when we take the square root of something, like the square root of 4 is 2. The square root of 9 is 3, because we are saying what number did I multiply by itself to get that value. So if I have 2 times 2, that means that would be the square root of 4 times the square root of 5, because 2 times 2 is 4. The square root of 4 is 2. Square root of 5, I can't simplify that. So we get the square root of 20 is equal to 2 root 5. Okay. Let's think of another value. So let's do, and some of these I might make up and they're not going to work out at all. Let's do the square root of 40. Let's do 42 because we already did one that ends in a 0. So 42. Pretty sure I picked one that can't be broken down anymore, but that's okay. We're going to go with it. So the square root of 42, 42 is broken down into 6 and 7. 7 is prime. 6 goes down to 2 and 3. So that means the square root of 2 times 3 times 7. I don't have anything that has 2 of a kind, so square root of 42 cannot be simplified anymore. Okay? So let's do another one. Try to think in my head a little bit here. Actually, I know what I'll do. I have an idea. Let's do the square root of 48. I think that one will work out a little bit better. So 48 is 6 times 8. 6 can be broken down into 2 times 3. 8 can be broken down into 2 times 4. And then 4 is 2 times 2. So that means the square root of 48, I have 1, 2, 3, 4 2's. Holy cow. 1, 2, 3, 4 2's, and then a 3. So then here's the other way I like to show it in case people don't see that we can take the square roots of things evenly. Every time, since I'm doing the square root, I look for pairs. So I have 2 2's there, 2 2's there. So what that means is this pair, if I take the square root, that's 4. So I would have the square root of 4 is 2. So I have 1 2 out front, and I have another 2 out front. And then under my radical, all we have is a 3 there that we can't do anything with. So then we take 2 times 2, so that is 4 times the square root of 3. Okay. So that's simplifying radicals. The next thing, just because I don't want this video to be too long, is simplifying rational expressions. This is something that I probably should have had some questions made up ahead of time. But if you look in your finish line book, they will have some good ones there. I'm going to start off pretty easy just to show you what we do with this before we really get into the factoring portion of it. So if I have the expression, we'll start off fairly easy. Let's do 2x plus 4 divided by x plus 2 in the denominator. And they are just asking us to simplify this expression. So if we look at it, I can't really simplify anything. So look at the numerator and say, okay, what can we factor out of 2 and 4? So look at all of your expressions and see if they're factorable. So the first expression, the numerator, I can factor out a 2. And we're left with the expression x plus 2 in the numerator, divided by x plus 2 in the denominator. Now, since both numerator and denominator have the same expression, see how they both have an x plus 2? I can cancel out the entire expression. I can't cancel like just the 2's or just the x's. It has to be the entire expression. So this whole thing then reduces to just 2. Now you'll probably see on the Keystone where they will have like a little condition here that says x cannot equal negative 2. The reason being, and you'll get into this more in Algebra 2 and definitely Algebra 3, because if x were a negative 2 here, a negative 2 plus 2 is 0, and you are not allowed to divide by 0. So it gives you your domain restrictions, okay? I don't really think they're going to ask too much about domain restrictions in Algebra 1. All right, so let's get into something a little more complicated. Let me multiply some things in my head. All right, so let's do x squared plus 4x plus 4 all over x squared. Wish I had a pen. Oh, I do have a pen. I can just multiply some things quickly so that I make sure while you guys write that down. To make sure I get something we can actually reduce. Okay, so x squared plus 5x plus 6. So when we have a trinomial divided by a trinomial, what we need to do to simplify this is to factor both expressions. So I'm going to color code these for you. We're going to do the top one in purple, bottom one in pink. So my top expression that I'm going to factor. Remember how to factor. We say what two numbers added together to give me my middle number, but when I multiply them, I get the product of the first and the last, so 1 times 4 is 4. Now the only factors of 4 are 1 and 4 and 2 and 2. Well, 2 plus 2 is 4, and 2 times 2 is 4. So that means my top expression simplifies into x plus 2 times x plus 2. Now we need to do our bottom trinomial. So I need two numbers that add to give me 5, multiply to give me 6. Now be careful here because I have 1 and 6 that could give me 5, but I also have 2 and 3 that could give me 5. So since they're all positive, it's going to be a positive 2 and a positive 3. So I have x plus 2 times x plus 3. Now, what do you notice about this? Anytime we have a fraction and we have the same thing in the numerator and the denominator, those two things cancel. So what can cancel for this problem? Well, if you said my x plus 2 up top and my x plus 2 in the bottom, you are correct, which means my final answer is x plus 2 in the numerator times x plus 3 in the denominator. Right, so that's an example on simplifying rational expressions. So there are more examples and different examples in your finish line book, so you can look over those, try to work on stuff today. We still have Monday that I can go over any questions with you, any problems you have, just let me know.